12 Science Subject Mathematics and Statistics Part 1st Chapter number 4 Pair of Straight Lines. Dear students, in last lecture we studied examples of find combined equation and find separate equations. Today we are going to study find the combined equation of the lines passing through the origin and perpendicular to the given lines. Examples. Example first. Find the combined equation of pair of lines passing through the origin and perpendicular to the lines represented by 3x square plus 2xy minus y square equal to 0. We are given that the equation passing through the origin, that is 3x square plus 2xy minus y square equal to 0. We know that the standard equation passing through the origin is ax square plus 2hxy plus by square equal to 0. This means these are two lines. We have find also two lines, but these lines are perpendicular to given lines. Solution. Let m1 and m2 of the slopes represented by 3x square plus 2xy minus y square equal to 0. Comparing this equation with standard equation, we get a equal to 3, 2h equal to 2 and b equal to minus 1. We know that sum of the slopes, that is m1 plus m2 equal to, formula is minus 2h divided by b equal to, put the values minus 2 divided by minus 1 equal to 2. Also product of the slopes, that is m1 multiplied by m2 equal to a divided by b equal to 3 divided by minus 1 equal to minus 3. Now required lines are perpendicular to given lines. These are two given lines, but our required lines perpendicular to these given lines. The given lines have slope m1 and m2. Therefore, required lines have slope minus 1 divided by m1 and minus 1 divided by m2. We take minus and reciprocal of the slopes as the lines are perpendicular, and required line passing through the origin. Therefore, their equations are the lines passing through the origin. We know that the equation is y equal to mx. Here m is line of first slope, that is minus 1 divided by m1, and slope of second line is minus 1 divided by m2. Putting these values, we get these equations are y equal to minus 1 divided by m1 into x and y equal to minus 1 divided by m2 into x. Multiply m1 with LHS, we get m1y equal to minus x. m2 multiply with y, then m2y equal to minus x. Take all the terms on LHS, therefore x plus m1y equal to 0 or x plus m2y equal to 0. These are two required lines. We have to find combined equation of lines. Therefore, suppose first line u equal to 0, second line v equal to 0, we know that combined equation is u into v equal to 0. Putting these values, we get their combined equation is x1 plus m1y into x plus m2y equal to 0. Multiplication x into x, x square, x into m2y, then m1y into x. Take common xy from both the terms, we get m1 plus m2 into xy plus. Here is m1y into m2y, m1 into m2 y square. Here slope, sum of the slopes and is product of the slope. We know that sum of the slope from this equation is 2 and product of the slope is minus 3. Putting this value, we get x square plus 2 into xy plus minus 3 into y square equal to 0. Therefore, the required lines are x square plus 2xy minus 3y square equal to 0. Example second. Find the combined equation of pair of lines passing through the origin and perpendicular to the lines represented by 5x square plus 2xy minus 3y square equal to 0. Solution. Let the given equation is 5x square plus 2xy minus 3y square equal to 0, denoted by equation 1. Compare with ax square plus 2hxy plus by square equal to 0. Here is x square coefficient is a, here a square coefficient is 5, therefore a equal to 5. Comparing coefficient 2h equal to 2 and b equal to minus 3 is a equal to 5, then h equal to 1, b equal to minus 3. Let m1 and m2 be the slopes of the lines represented by equation 1. This is a pair of lines passing through the origin. Hence it have two lines, therefore two slopes m1 and m2. We know that sum of the slopes, that is m1 plus m2 equal to minus 2h divided by b. Putting the values we get minus 2 divided by minus 3 equal to 2 divided by 3. Also, the product of the slopes m1 and m2 equal to a divided by b equal to minus 5 divided by 3. But the required lines are perpendicular to given lines. Therefore, their slopes are minus 1 divided by m1 and minus 1 divided by m2. Minus and take the reciprocal of first line, minus and reciprocal of second line, as the required lines are perpendicular. Therefore, their equations are these lines passing through the origin, therefore its equation is y equal to mx. Put m is slope of first line minus 1 divided by m1 and slope of second line is minus 1 divided by m2. We get the lines are y equal to minus 1 divided by m1 into x and y equal to minus 1 divided by m2 into x. m1 multiply with y, then m1y equal to minus 1 into x minus x, and m2 multiply with y, m2y equal to minus 1 into x minus 1, x. Minus x, take on LHS, we get x1 x plus m1y equal to 0. Also minus x, take on LHS, we get x plus m2y equal to 0. These are two required lines. We have to find joint equation. Suppose this line u equal to 0, this line v equal to 0. We know that the joint equation is u into v equal to 0. Therefore, the joint equation x multiply with first term, that is x square, then x multiply by m2y, that is m2xy, then m1y multiply by x, m1xy, m1y multiply by m2y, m1 into m2 y square equal to 0, x square. Take xy common, then we get m2 plus m1 plus m1 multiply by m2 y square. We know that sum of the slopes and product of the slopes are. Here we have to find sum of the slopes is 2 by 3 and product of the slope is minus 5 by 3. Putting these values in this equation, we get x square equal to 2 divided by 3 into xy minus 5 divided by 3 into y square equal to 0. Multiply this equation by 3, we get 3x square plus 2xy minus 5y square equal to 0. These are the required lines. Example 3. Find the combined equation of the pair of lines passing through the origin and perpendicular to the line represented by 5x square minus 8xy plus 3y square equal to 0. Solution. Compare the equation 5x square minus 8xy plus 3y square equal to 0 with ax square plus 2hxy plus by square equal to 0. Coefficient of x square is a equal to 5. Coefficient of x square 2h equal to minus 8. Coefficient of y square, that is b, equal to 3. Therefore, a equal to 5, 2h equal to minus 8, b equal to 3. These are two lines. Suppose let m1 and m2 be the slopes of the lines represented by 5x square minus 8xy plus 3y square equal to 0. That is, slope of first line is m1, slope of second line is m2. This is pair of lines, that is two lines. We know that sum of the slopes, that is m1 plus m2 equal to minus 2h divided by b. Put the values, then 2h equal to minus 8 is minus equal to plus 8 divided by b is 3, and product of the slope, that is m1 multiplied by m2 equal to a divided by b. Put the values 5 and 3, we get 5 divided by 3 denoted by equation first. Now the required lines are perpendicular to these lines, therefore slopes are minus and take the reciprocal of first line, that is minus 1 divided by m1 is slope of first line. Also minus and slope reciprocal of slope of second line, that is m2, then we get minus 1 divided by m2. Since these lines are passing through the origin, the lines passing through the origin have equation y equal to mx. Here is two lines, slope of first line, slope of second line. Putting this, we get y equal to minus 1 divided by m1 into x and y equal to minus 1 divided by m2 into x. Taking m1 multiply with LHS, m1y equal to minus 1 into x. m2 multiply by y, m2y equal to minus 1 into x minus x. Minus x, take on LHS, x plus m1y equal to 0. Here is minus x, take on LHS, then x plus m2y equal to 0. Therefore, their combined equations is x plus m1y and x plus m2y equal to 0. Here is x square plus m1 plus m2 into xy plus m1 multiply m2 equal to y square. Then put the values of sum of the slope, that is m1 plus m2 and m1 multiply by m2 from equation 1. We get x square plus 8 divided by 3 into xy plus 5 divided by 3 into y square equal to 0. Multiply with 3, we get 3x square plus 8xy plus 5y square equal to 0. These are the required lines. Example 4. Find the combined equation of pair of lines through the origin and perpendicular to the line represented by xy plus y square equal to 0. Solution. Compare the equation xy equal to xy plus y square equal to 0 with ax square plus 2hxy plus by square equal to 0 we get. Here is coefficient of x square is a. Here the term x square is absent, therefore a equal to 0. Coefficient of xy is 2h, coefficient of xy is 1, therefore 2h equal to 1. Coefficient of y square is b, here coefficient of y square is 1, therefore b equal to 1. Let m1 and m2 be the slopes of the lines represented by xy plus y square equal to 0. Therefore, sum of the slopes, that is m1 plus m2 equal to minus 2h divided by b. Putting the values, we get minus 1 divided by 1 equal to minus 1. And product of the slopes, that is m1 multiplied by m2 equal to a divided by b. Putting the values a and b, we get 0 divided by 1 equal to 0, denoted by equation 1. As the required lines are perpendicular to these lines, therefore their slopes are minus, and take the reciprocal of slope of first line minus 1 divided by m1. Also, from the second line, its slope is minus 1 divided by m2. Since these lines are passing through the origin, therefore their separate equations are y equal to minus 1 divided by m1 into x and y equal to minus 1 divided by m2 into x. Therefore, m1 multiplied by y equal to minus 6 and m2 multiplied by y equal to minus 6. Take minus x on LHS, then x plus m1y equal to 0 and second line x plus m2y equal to 0. This line is suppose u equal to 0, v equal to 0. We know that their combined equation is u into v equal to 0. Putting these values, we get x plus m1y into x plus m2y equal to 0. Multiplying and simplifying, we get x square plus m1 plus m2 into xy plus m1 into m2 into y square equal to 0. From equation 1, sum of the slopes is minus 1 and product of the slope is 0. Putting these values, we get x square into minus xy plus 0 into y square equal to 0. Therefore, x square minus xy equal to 0. These are the required lines. Example 5. Find the combined equation of pair of lines passing through the origin and perpendicular to the line represented by 3x square minus 4xy equal to 0. All 5 examples are of the same type. Here we solve this example by direct method. Solution. Consider 3x square minus 4xy equal to 0. Take x common, then x into 3x minus 4y equal to 0. These are two separate lines. Here is combined line. Separate equation of the lines are x equal to 0 and 3x minus 4y equal to 0. Both are passing through the origin. This line x equal to 0 is the equation of y-axis. That is this line is y-axis. Let m1 and m2 be the slope of these lines. Then m1 does not exist as x equal to 0 is the equation of y-axis. Y-axis have not slope, therefore m1 does not exist and m2 equal to. Here is this line. Then we have to find its slope is minus coefficient of x is 3 divided by coefficient of y is minus 4. Then we get m2 equal to 3 divided by 4. Now required lines are perpendicular to these lines. Therefore their slopes are minus 1 divided by m1 and minus m divided by m2. Since m1 does not exist, m1 does not exist. m1 does not exist, hence this line is y-axis. Here is the required lines are perpendicular. Therefore the required lines have slope minus 1 divided by m1. Y-axis is first line. Perpendicular line that is perpendicular of y-axis is x-axis. Hence the slope of the x-axis is 0. Hence we take minus 1 divided by m1 equal to 0. Also m2 equal to 3 divided by 4. The line is perpendicular to given line. Therefore minus 1 divided by m2 equal to minus 4 divided by 3. Since this line passing through the origin. Therefore their separate equations are, here is y equal to 0 is the equation of x-axis. X equal to 0 equation of y-axis. The x-axis are perpendicular to y-axis. Therefore its equation is y equal to 0 and second line y equal to mx. Here is m is minus 4 divided by 3 into x. We take slope is minus 1 divided by m2. Simplifying we get 4x plus 3y equal to 0. These are two separate lines. We have to find combined line. Suppose this line is u equal to 0 and second line v equal to 0, then their combined equation is u into v equal to 0. Therefore multiply with y, then 4xy plus 3 into y into 3y equal to 3y square equal to 0, which are the required lines. Thank you.